Hello everyone, my name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies. All right, so let's dive in. So today I'm going to talk about MongoDB as an open standard for document databases. So the reason I'm very interested in this topic is because the reason why we've built FerretDB and the reason why we've been doing what we're doing for close to 3 years now is because there is a group of users who chose an open source database. They chose MongoDB as their main database. And I will be talking a bit more about this later on. When MongoDB changed the license to their SSPL license, which is not an open source license, then they basically found themselves in this situation where they chose an open source database and then they ended up with a proprietary one. And we think that it can be replaced by Postgres on the long term, MongoDB, that is. So, quick introduction of the company. I promise I will not talk much about the company itself. So we have three co-founders, Alexei Palaschenko, Peter Zaitsev, and myself. We all came from the company called Percona, which is an open source database consulting company you might have heard about. So, just a quick recap of our agenda today. We're going to talk about MongoDB's licensing, the history of SQL as an open standard, the MongoDB query language as an open standard, the architecture of FerretDB, and then we will conclude the presentation. So this is the Stack Exchange Developer Survey of 2024. Or a little portion of it concerning databases. And so this survey asked developers, which database environments have you done extensive development work in over the past year, and which do you want to work in over the next year? It had 67K responses, so a pretty representative survey if you ask me. And so the results of this survey is very interesting. First of all, it's not a surprise that Postgres was by far the most coveted database technology among developers. Then it was MySQL, SQLite, MongoDB, and Microsoft SQL Server. So there is one outlier on this graph, and well, judging from what my presentation is about, you might have figured out that it's MongoDB, but why is that? So the reason why MongoDB is an outlier on this graph is because, first of all, it is the only document database, and second, among its peers, it is the top one database, but not open source. So Postgres, MySQL, and SQLite are all open source, but MongoDB isn't. So basically, if you want to work with a document database and you want to work with the top document database, your only choice is really a proprietary database. So whenever I present a similar or this presentation, the question comes up, wait, isn't MongoDB open source? Because of course, MongoDB started out as an open source database, and lots of users liked it, and it gained market traction because of its open sourceness for the most part. But they changed the license in 2018 to this license called the Server-Side Public License, or SSPL. And SSPL, while MongoDB claims it's an open source license, it is not recognized as such by open source organizations such as the OSI. The reason why it is not regarded as an open source license is because it doesn't come with the same freedoms as most open source, or well, all open source license should. Mainly, it discriminates against use cases. So, for example, if your MongoDB database is used as part of a cloud service, then you might be in a situation where the SSPL would mandate you to open source your entire stack, or SSPL your entire stack, which is used for that, for providing that service. So that doesn't make me remember how open source licenses should work. You can also decline to SSPL your entire stack, but then you will have to pay a license fee. So why do we even care about that? You can just SSPL your stack and call it a day. Well, the reason why users should care about the SSPL license, the reason why this is bad, not just for service providers like Amazon or Azure or whatever have you, is because it kills innovation and creates vendor lock-in. So if you think about it, the less providers you have who are licensed to provide MongoDB as a service, the less competition there is on the market. And if there's less competition on the market, that means less innovation and higher prices for the users. So there is this website which tells you more about the effects of SSPL on the broader user community. It's ssplisbad.com. I don't know who created that website. I don't know anyone who would be affiliated with it, but they did a pretty good job with explaining what's up. So we established that MongoDB is no longer open source. Let's ask the second most common question: why not just use Postgres and JSON? Because there's JSON support for document workloads in Postgres. So in theory, you can just depart MongoDB and use Postgres. Well, in reality, it's harder than you might think. So MongoDB dominates the document database market, and so a lot of frameworks, a lot of existing applications, a lot of tools, and of course, the skills and knowledge of developers are built around MongoDB. So that means that it's pretty hard to not just rewrite applications, but also to relearn lots of the skills and knowledge needed to build applications for the sake of using Postgres might not be feasible for many organizations. So JSON support is great, but the existing frameworks and the existing developers might not be comfortable with what it offers. So today's presentation is also going to be about the short story of SQL, and I promise that it is going to make sense moving forward on why I'm mentioning this. Some of you might already have figured out the why, but of course this is a short presentation, so it's not going to be historically accurate, but still my aim here is to provide a quick recap, so it will provide a bit more context to this situation with MongoDB. So the short story of SQL, the short history of SQL, well, it started, SQL has a long history. The reason I'm saying short history is because what I'm going to present is the very short version. So IBM came up with the relational model and with SQL as well. The relational model was developed by a person called Edgar or Ted Codd, who was a researcher at IBM Research Labs. So he came up with the relational model, which we all use in Postgres. And he also came out with the first query language for this relational model, which was crazy complicated. You actually had to write an application, a separate application to query data from your relational database. So while it was a groundbreaking new model in database technology, the query language was very complicated and could only be understood by hardcore developers of the time, not end users for sure. So this was in the 70s. So also in the 70s, there were two other colleagues of Edgar Codd at IBM, Don Chamberlain and Ray Boyce, who recognized this problem with the relational model, that there is no viable query language for end users. And they came up with SQL, which is this very easy to use English-like query language for relational databases. And this is what really enabled the relational technology to gain traction, because finally there was an easy to use way to query your data from and also to insert it to the database. One very sad but interesting addition is that Ray Boyce was 20-something years old, and he actually died of a brain aneurysm shortly after publishing the paper on SQL with Don Chamberlain, and so he never had the opportunity to learn the profound impact he had with this paper on the world of information technology. In any case, SQL and the relational database gained traction on IBM computers. So it ran exclusively on IBM computers, and the product was named IBM DB2. Some of you might be familiar with this product. It's actually an interesting one. So IBM released the IBM DB2 product on their machines, and you had to lease these washing machine sized computers if you wanted to use this technology. So if you liked SQL, you had to lease one of these. You couldn't run it outside of an IBM environment. Does this make you think that we might be doing the exact same with cloud and all that? So you had to lease someone else's machine to run the software you're skilled in and what you like. In any case, if you wanted to use a relational database those times, you had to use IBM. And then some others came up with alternatives as expected. So there was Informix, Sybase, or a relational software systems Inc., which is nowadays known as Oracle. So these alternatives appeared on the market, and these were an implementation of the relational model and SQL. However, these alternatives were not based on any kind of standard in connection with SQL, which meant that they implemented it based on the behavior of IBM DB2 or based on what they saw fit on how this should work. So at the end of the day, they came up with similar products, and this was really helpful to users. However, there was no conformity between these products. If you knew SQL, you kind of saw similarity between these products, but they were not compatible with each other. But at the end of the 80s, SQL was established as an open standard. So finally, vendors and researchers and users came together, and they created the SQL white paper, which described how SQL should be implemented, how it should behave. So if you were a user and your database product had some degree of conformity with the SQL standard, then you could have expected similar behavior. And that's when this open standard enabled open source projects like Postgres, like MySQL, like SQLite, and hundreds of different derivatives of the SQL standard to be implemented in a way which could be used by many more users across many different systems out there. So when SQL became an open standard and when open source projects picked up the SQL standard, that's when the relational model and SQL got this chance of word domination, where anyone with a computer could use the relational model, benefit from it without fear of vendor lock-in. So I promise that it's going to make sense for me to start describing the history of SQL. And so let me explain why I did this. So you might think that this is just a distant memory where, you know, you lease washing machine-sized machines just for the sake of using a database technology you like and you're comfortable with. But actually, this is the reality of lots of users around the world, lots of developers around the world. So this is not just the thing of the past. If we look at document databases, as I mentioned earlier, MongoDB was an open source database, so many users chose it for the sake of avoiding vendor lock-in. So it's rather different from SQL, which started out as proprietary. But in any case, MongoDB is no longer open source. If you want to use it, you need to use MongoDB Atlas or some cloud service, or the less feature-rich community edition. But still, you are unable to use it as a service, for example. So you have to lease someone else's machine as part of the cloud, or you have to make sure that you abide by the SSPL license in order to use MongoDB. So MongoDB had the very similar promises. You don't need to be a DBA to run a database. It's much easier than the database technologies of the time, or relational. So it had very similar promises as SQL itself back then, and that's why it captured the attention of many developers out there. So there is this very interesting similarity between the history of SQL and MongoDB, where after the license change in 2018, lots of alternatives appeared on the market. I think this slide might be very familiar. It's just I replaced SQL with the MongoDB query language, or MQL, and the alternatives are also well, not so much compatible with each other, because even though these alternatives you can see on the slide all did a great job in trying to mimic the behavior of MongoDB, they are not compatible with each other. They don't share the same or similar feature set, and in many cases, the behavior is different. So if you're a MongoDB user, that doesn't mean that you can just get out of your vendor lock-in situation by switching to one of these. It might be possible, but it is very likely that you will have to relearn some things, and you might also need to do a rewrite of your application. So once you choose one of these, you're kind of stuck with that. So the issue with MongoDB alternatives, and this was a problem with the SQL alternatives as well, is that the feature set is different. The compatibility is not quite there between them. Migration is hard, and these alternatives might also be tied to specific cloud vendors. But for the most part, using an alternative of something is also challenging, because for the alternative, the original implementation sets the pace. So what if MongoDB deprecates something? Will alternatives need to deprecate that feature as well? Or will alternatives need to share the same developer roadmap with the original implementation just to stay compatible? Sometimes that doesn't make sense. So this is why I think that we are in need of a new open standard, a very similar standard to SQL, which explains how MongoDB or MongoDB-like document databases should operate. How I imagine this, or we imagine this, as there are quite a lot of vendors and developers out there who are looking forward to this, would be a standardized core feature set based on MongoDB, a JSON-like query language, and basically a core which explains how the database should behave, which could be extended of course, beyond what the standard mandates, just like with relational databases. But establishing this core would ensure that there is a possibility to migrate between these products, to use the same skill set you have to move to any alternative which implements the standard. And this would stimulate innovation and increase competition to the same degree, or a very similar degree, as how it happened with SQL. And that's why I talked about the story of SQL in today's presentation. So as the SQL standard was really good for users, we believe that a standard around document databases would have a similar effect. So what did the community do, and what did we do to make this happen so far? I promise this is not going to be a sales pitch. Of course, I'm affiliated with FerretDB. We think that FerretDB was one of the first steps towards this standardization, since we developed a MongoDB compatibility layer, a fully open source one written in Go, which uses Postgres as the backend. So we basically turn Postgres into a MongoDB compatible database, which can be used anywhere, and it comes with the same freedoms as any other open source database, as it is released under the Apache 2.0 license, well, that's a real open source license without strings attached. So what we mean by MongoDB compatibility, it means that existing elements of the MongoDB ecosystem, so that is a tool or application or framework, are possible to use with FerretDB or any of the compatible alternatives, meaning that developers don't have to relearn their database technologies. They don't have to rewrite their applications. If you connect to FerretDB, which stores data in Postgres, well, it behaves just like MongoDB, meaning that your application will not even notice that that it is not running on MongoDB proper. So MongoDB compatibility means basically the freedom to migrate away and migrate your MongoDB workloads to Postgres. Just a very quick kind of overview on the architecture and licensing. So as you can see on the top chart, this is how MongoDB looks like from a licensing perspective. The MongoDB drivers are Apache 2.0, and the Mongo API and the database engine, which was called WiredTiger. It was purchased by MongoDB for the purpose of the database engine behind the MongoDB experience, are licensed with the SSPL license. So the MongoDB drivers are or may be part of the application developers, right? Meaning that the license can't really be changed to SSPL. And the MongoDB drivers are the, well, that's the portion which really provides this smooth experience for developers to develop for MongoDB. And so since it's still Apache 2.0, if you look at the bottom chart, we can just use these MongoDB drivers to interface them with FerretDB instead of MongoDB, which emulates the MongoDB API, which then interfaces with Postgres or the Microsoft's DocumentDB extension. And these are all licensed as either Apache 2.0 or MIT, the Postgres is licensed, meaning that the full experience would again be open source. So that's why we want to bring the MongoDB experience, to bring MongoDB to Postgres, and that's how we did it. The interesting thing about FerretDB is that since we turned Postgres into a MongoDB compatible database, we can also turn Postgres as a service providers into MongoDB as a service provider just by running FerretDB on top of their Postgres offerings, which was the very thing SSPL did not allow providers to do, meaning that users of these platforms or any Postgres provider can leverage the power of MongoDB and use the same provider for both Postgres and their MongoDB needs. Another huge step towards the standardization effort here is that we had the pleasure of working together with Microsoft. It took more than a year to release FerretDB 2.0, which uses the same engine as Azure Cosmos DB for MongoDB, which is an open source alternative to MongoDB built on Postgres. And so FerretDB 2.0 is largely compatible with Azure Cosmos DB for MongoDB, meaning that the current alternatives are moving closer and closer to provide a common feature set. And so it enables users to switch over or switch between these two MongoDB alternatives, which was previously not possible. And this is how standards are being born even before someone writes a single line of text into a white paper. We also have the OpenDocDB effort at opendocdb.org, which is a community-led push for standardization. We think that it might make sense to certify compatibility first and write the standard later, meaning that we have a tool which which looks at the current alternatives, either FerretDB or Azure Cosmos DB or AWS Document DB or Oracle's MongoDB API. It compares the feature set of these, and we are coming up with a common feature set which these alternatives will be tested against, and then we can say whether these alternatives are compliant with the OpenDocDB requirements or not. Kind of similar to how some of the web-based standards were born in connection with CSS or even HTML. And this effort is supported by quite a lot of companies in the Postgres community, and I would invite you to visit the website to learn more about our manifesto and this effort and the standardization in general, especially if you would like to take part in it. So the conclusion, there is a need for an open standard for document database as far as we believe. We think that MongoDB is going to be the same kind of commodity just like SQL is. We do build this with the community, whether that is FerretDB as an alternative to MongoDB based on Postgres, or the standard itself. So if you would like to join this effort, if you're interested, please don't hesitate to reach out to us, to try FerretDB, to look at the current progress on GitHub. And if you would like to connect on LinkedIn and talk a bit more about this, then I'm more than happy to do that as well. With that, thank you so much for your attention today, and I wish you a good rest of the conference moving forward. Thank you so much.